Hi, everyone. Welcome to Designing Production APIs That Last. Today, we're going to talk about some reasons that production APIs are lasting today, why some production APIs are not in there for the long term, why they're experiencing some problems potentially, and then potentially some solutions that we can apply on top of that to improve the experience. So to borrow this metaphor from Grace Hopper, a ship import is safe, but that's not what ships are built for. Design begins the moment we start thinking about the problem we intend to solve. How often do we think about what it takes to prepare this design for real-world deployment, observability, and debugging scenarios? After all, we're working in an iteration. We have time constraints. Version 1 needs to get out the door. In this SmartBear 2020 State of the API report, it shows that lots of organizations actually have a formal API design process. For many of them, especially larger organizations, it's a top priority. If you look at the Postman 2020 State of the API report, we're looking at time allocated with APIs. It shows that the bulk of time, of course, is spent coding, programming APIs. Below that, we see debugging, manual testing, and automated testing, which isn't too surprising. But then right below that, we see designing and mocking APIs. So we know it's of some importance to design APIs. It's not at the bottom of the list, although it's maybe a little difficult to piece out how much of that is designing versus mocking. I think it gives us a good indicator of where it sits in terms of time allocated. So back to the SmartBear 2020 State of the API report. When asked to name the top 3 concerns as an API provider, functionality was listed right under availability. So not having availability means no one has access to your API, or you have reduced access to your API. So clearly that's number 1 for almost any organization, probably all organizations. So right underneath that, we have functionality. Now that's a big one, right? Because functionality and design are actually linked together. And one more chart here, and back to the Postman 2020 State of the API report. How frequently do APIs break? So we know that APIs and API processes are important to organizations. We know that we're investing at least some time into that design. We know that functionality is a top concern for APIs. And with all that in mind, we're still breaking 40 to 50% of the time. So for some of these folks, it's daily, weekly, monthly, too frequently. And then this sort of last section here is not often enough to matter, which sounds like a very subjective answer there. What does matter? I suspect that a lot of folks in the light blue here are having issues, are experiencing defects that are likely going undetected. So, what happens when our ship leaves port? Clearly, 40 to 50% of us are underwater still, and you can look at some of these charts and feel a bit optimistic, and I think that's warranted to a certain degree, but there's still a very long way to go. So this picture you might be familiar with. It gets referenced in survivorship bias, and so in this case it's a military case. They're looking at planes that are coming back and saying, perhaps we should be fortifying these areas that did not get hit with bullets, as opposed to those that did get hit with bullets, because in these planes that have returned, the ones that weren't hit in these spots survived. We can take this model. It applies to a lot of different areas of life, but we can also apply it to APIs. We can look at those APIs that are breaking frequently and ask why, go deep, look at those questions. We can also take a step back and look at the APIs that are succeeding and ask why those are succeeding. I think both have their merits. We're going to start with the latter here. Now, this is all based on sort of anecdotal evidence, what I've seen out in the wild, folks who I've talked to who are doing this. But it seems to me that most APIs last by having simple design and simple use cases. So some of these use cases are fairly minimal. Do you need to fetch product data to display in an app? Once the design is finished for these, it's likely to stay pretty much the same for a while. So not a lot of change, not a lot of evolution. It's easy to duplicate in multiple environments. It's easy to test. It's easy to debug in production. Life is good. And so, the first thing I think to do is evaluate if you can keep your API simple, because that is sort of the best case scenario. Start simple if you can. It's going to lead to quicker design loops. It's going to lead to quicker lead time, quicker release, and that's what you're looking for in many cases. Of course, to have that as a goal and be a useful goal, you need to actually keep your use cases simple. Now, what I typically recommend is kind of mapping out your application model as it pertains to your API consumer use cases. And if we try to match those things up as closely as possible, what we end up with is what's been called experience APIs. Sometimes the concept is rolled into backend for front end. Whatever you want to call it, it's a simple use case that requires a simple API. But what happens when life is a little bit more difficult than this, as it often is in business applications? What happens when you have necessary complexity? As your APIs begin modeling more complex use cases, this is where we'll start to see some trouble. We'll see modeling exercises like event storming, and various others to create what the models are going to look like for our APIs. And one sort of important aspect here is that when that complexity starts to increase and becomes necessary, we're not just looking at data anymore. We're also looking at behavior. Let's take a look what that might look like. So when we begin modeling something complex, we start with the way we've known to build more simpler APIs, right? A simple read operation, we'll grab a core here and see that the temperature says, oh no. It's a nice pattern. It makes us feel good. We know it. It's a warm blanket everyone loves. But what happens on the next request? This time we're making a post to that same path, and we're adding a request body of op implode. So we begin designing ways to communicate operations between client and server. But how did we even get here? Was there any indication that implosion was an option? What informed this decision? This is where we ask the question, who owns application state and how is that communicated? Which brings us to our next point. What actually made that first example simple? Sure, the use case was simple, but what about the API message itself lent to an easier experience? Well, everything that we needed in that case was actually in the message, right? We could get the product, we could see all the data points associated with it, and we had essentially just a read use case, right? So the consumer use case was to get that data and display it or record it somewhere, and that was a minimal need. But as these APIs, as these models start to increase in complexity, can we apply some of the same principles? And we have to ask, who is the message's intended audience? When we think about request and response bodies or event messages, typically we go through a few phases. At first we get stuck in this idea that, the message over the network is just for the machines, just one machine talking to another. And if that were true, we'd all probably still be using XML for message bodies right now. It gzips fine. The byte size can be fairly small, can be self-descriptive. There's a lot of benefits to that. But why did we stop using it? The most commonly cited reason is that humans found it difficult to read and difficult to write. Now, let's think about that for a moment. if these message bodies were meant just for machines, this would have never been an issue, but they aren't. Messages are made for humans as well. And what happens when this API goes to production? We need to debug it. We need to look for anomalies. We need to look for defects. We need observability tools on top of it to figure out what's actually going on. These are all humans at some point who are looking at these messages. So, knowing that humans are going to have a stake in this game, they're going to be looking at these messages, why don't we take this concept and bake it into the design as we start thinking about how to build our APIs? The application state carries so much context about what's actually happening when something goes wrong. We need to think about this when examining APIs in production. Okay, so how do we do that? There are a number of different ways. I'm going to propose one. The interesting thing about user interfaces, command line interfaces, application programming interfaces is that they're all interfaces. They're one way to expose data and controls to someone else, and that other entity can interact with it, right? So what can we learn about modeling complex operations on top of APIs? This is an old example that I use. It goes back 20 years. This is Microsoft Money 2000. So for folks who weren't around then, this is personal finance management software. This is actually fairly difficult to wrap one's head around a lot of times. Accounting practices in general are non-obvious to a lot of folks, which makes the whole need for personal finance management software out there. And so the Microsoft Money 2000 team, recognizing this complexity and this difficulty, had this realization. They realized that a lot of the user interfaces out there were what they called deductive. You'd be presented with a lot of information and then have to kind of figure out what you do on your own. So in kind of our API sense, we just get a big bucket of data, perhaps a very large bucket of data, and then have to make decisions on our own based on that data without necessarily knowing what the application supports. So it actually leaves a lot of room for error. And the Microsoft Money team had this idea of kind of flipping that on its head and creating what they call the inductive user interface. So strangely enough, this is actually an interface that they borrowed from how people were building web applications at the time. So, they took this model of web design, of having hyperlinks, of, being able to do some navigation. And they said, well, this kind of applies to desktop software as well. And so in doing so, they actually came up with this really great guide that's published for free on Microsoft right now that outlines different steps that you can take to create an interface like this, to take all of this complexity and make it something a bit more palatable for consumers. So what I'm doing here is taking those steps that they defined and applying those to APIs. So we'll say step one, focus each message on a single task. So that task should be something API consumers might think to do, preferably described in their own words. Again, we're talking about experience APIs here. So, a direct consumer use case for this API that we're interacting with. What are they looking to accomplish? Why are they here? The interface should make it extremely clear about what the API consumer should do while here. And there's a number of different ways this can happen. So we talked about focusing the message on a single task. We have to make the message body, we have to design paths and relationships clearly and concisely. Are they displaying product information? Are we showing the status of a nuclear core or the core of a star? This applies to event-based messaging as well. So, what channels are we using to push this information over? It is worth it to spend a bit of time in design figuring that out. because the clearer that is, the more clarity you have there, the clearer it's going to be to that consumer and their use case. Step 3 is make the message body suit the task. So the thought put into resource paths and relationships, event messages should inform the content of that message body. If you've done some modeling in advance for this particular project, this should actually be the easy part. An additional thing here, so this is the data properties that you'll have, really. An additional point here that the Microsoft Money 2000 team realized is that consumers need an exit point. They don't just need, here is the data associated with this particular task. They need to know what is the primary next step that I need to do. And so that there are a number of ways to go about displaying that, which we'll talk about in the next step here. So step 4 is to offer links and transitions to secondary tasks. So, if you're in a complex domain like, personal finance management, typically there might be a primary thing you're going to do next, but there's going to be a lot of other stuff you can do as well. And we want to make this clear and obvious. Again, like clarity is the key to having that successful adoption on the consumer side. There's plenty of work that's been done around this in the hypermedia space. I wrote something called Siren, which is a specification for hypermedia, response bodies. There's RESTful JSON is another one out there. There'll be links to these specs included in the presentation. They have great traction in modeling complexity. And an interesting point about that is a lot of times this kind of complexity exists deep within enterprises of specific domains. So, the kind of publicity around this stuff isn't as popular as some other technologies out there, but they definitely truly exist. So take that for what it's worth. And that makes us revisit this question again: who is the message's intended audience? So we've been, applying the user interface principles. We've been talking about the API consumer, but the reality is, it's not just API consumers that we're talking about; it's message consumers. So where do we consume these messages? It's not just in that sort of API interaction space. It's also in logs, metrics, observability tools, debug sessions. What happens when things go wrong? And something will always go wrong. We have to admit that the moment we start modeling a complex API, we're already getting it wrong. Given these design principles mentioned, how do you use them to help understand what our deployed application is actually doing? This is really what we're trying to get to here. My API is in some kind of production environment. It's doing something. How do we make sure it's doing what's intended? And when it doesn't do what's intended, how do we figure out what went wrong? So one way you can do this is to start including this in your observability tools. So OpenTelemetry is a collection of open source tools to help with tracing and now metrics and logs. It's common to collect spans in tracing to determine what's happening. So, you can think of little spans of time, between 0 and 300 milliseconds, this happened, between 300 and 600 milliseconds, that happened. You're able to add custom attributes to these spans. So when we talk about putting the application state into the message, it makes it really easy to start recording what the current state was into your tracing. So, what's the current context of the application? What was the consumer able to do next? As someone debugging this, you can follow each decision as it's being made. So again, include that application state not only in your traces, but in your structured logs. It's likely that your message is already in some kind of structured format, so take advantage of that structured logging. Again, that application state is going to come in handy. And it's important when talking about these observability tools to think about high cardinality. So high cardinality means recording data fields that might have a large number of potential values. or even recording data fields that might not be known up front. It sort of takes specific technology on the back end to make this feasible. There are a bunch of different products out there that are doing this. But this is one key to taking advantage of observability. Right? You can start to ask some really specific questions. Once you start storing all of this application state from the messages, you can look at the behaviors. What data are they looking at? What behaviors are they taking? Show me all API consumers who chose to implode a core today compared to how many users were presented with the option to implode a core. All of this gets represented in the message, and this promotes evolution. Now, consumers are very sensitive creatures. Many of the ways we can evolve an API are additive, so we can add a few fields here and there. Consumers who don't use them can ignore them. We can add new transitions, new relationships to the message. A consumer who doesn't understand them they could just do nothing. However, what happens when we want to take something away? The detailed observability gains you can achieve can let you dive in on who is using features you want to deprecate. What does their workflow look like, actually? Should we actually deprecate this feature? Are we wrong about the need to deprecate it? Does it not meet our customers' use cases at this point? Do we need to provide an alternative? Consumers, they're very sensitive to this. So how do we take care that we're always keeping those concepts in mind when building our APIs? This is where the term governance comes in. Now, governance as a term, it kind of makes me wince a little bit. I'm not too excited about it, but it is sort of the industry term we're using for this. And to do that, to come up with some plan of governance, how must my APIs comply? You need to come up with some constraints. Now, constraints are a double-edged sword, right? There's a time for broad exploration of ideas, of experimentation, testing different designs, and there's also a time for alignment. When we talk about governance, we're talking about figuring out how we're going to align on these constraints. Now, it's important to note that just like with your API design being something that is in flux and moving, you will also get your governance wrong. You will have to iterate that on a few times before you really figure out what's going to work for your organization in terms of the constraints that you're applying to your APIs. Some folks are doing this with OpenAPI, using linting tools on that. That's certainly one way. I'm sure the async API community has something similar for event-based messaging. Whatever it is you use to ensure it, designing it and figuring out is kind of the bigger challenge, in my opinion. So have the discussions, bring in the right folks. Don't stay too married to your first iteration there. We kind of have a habit, I think, in the industry of saying, well, it's already built, it's already there. It takes more effort to change it than it does to actually have the conversations and reap the benefits of changing it. So, speaking of bringing in the right folks, in the API space, we've talked about this concept of an API team for a number of different years. So this is a team that's going to be responsible for really all aspects of your API. Kristen Womack has a great post on this, actually. I think it's from 2016, but it still is incredibly relevant. Again, there'll be a link in the presentation. But your API team, these are the folks who will be stakeholders in this governance process and actually building out and monitoring and observing your APIs. These are product managers, solutions architects, developers, of course, support folks, developer relations, technical writers, analysts, executive sponsors. It's everyone. It's really everyone who has a voice in building products in your organization. Your API is a product, even if it's only internally facing. If it's treated like a product, you'll put in the effort to make it last. And some final thoughts here. This stuff is really hard. there's a big world out there. You've already heard a million different ways to solve your problems, and here's even more. The advice I follow when figuring out architecture is the simple advice given by Roy Fielding in his thesis on representational state transfer. And I think this is almost a more important aspect of that paper than the principles of REST that we follow today. But the flow documented there is to start with absolutely nothing. Pretend that you're starting from scratch here. What properties do you actually want your system to possess? What constraints can you apply to achieve those properties? And then what are the trade-offs of imposing those constraints? Keeping this stuff documented gives a certain sense of honesty to what you're building, and can be a really great way to communicate with your team, not only technically, but on the business side. In terms of scaling, even in terms of what you're offering to your business consumers. These constraints are extremely important. And really, I would say equally important is really knowing what those trade-offs are and how you can negotiate and compromise with that over time. So let's keep chatting. Like, the game isn't over. There's a lot more innovation waiting to happen in the API space. And then, we've seen a lot of it already. We'll see a lot more of it continue. Thank you. If you want to get in touch after this, I'm on Twitter. I'm on LinkedIn. Almost anywhere you can find me. My name is Kevin Swiber. So thank you so much. And I hope you enjoy the rest of your day.